Okay, I'm going to do about 6 questions. They're sort of multiple choice questions, but I'm just going to go straight into the answers. So first one, Mark, Helen and Peter are 3 friends who are all collecting coins. So 2 ratios of the number of coins owned are given below. Mark to Helen is 7:10. Helen to Peter is 15:7. Write the ratio Mark to Peter in simplest form. Good thing about this is that we have Helen as a common in the 2 groups here. So I'm going to make Helen the same ratio parts, because at the moment she's in 10 on the first one and the second she's in the 15 parts. So that's not going to work for us. Mark Helen equals 7:10. Helen to Peter equals 15:7. I need to make this 10 and 15 the same, and I'm going to use lowest common multiple. So 10 will go 10, 20, 30, 40 and so on. 15, we've got 15. It's like 1 times 15, 2 times 15, 30, and then 45 and so on. So the common lowest multiple is 30. So I need to change that 10 and 15 to 30 by times by 3 here, timesing by 2 here. Now when I do the one part times by 3 and times by 2, I'm going to do the same thing on the other parts. So now we have new ratios, which is 21, 30, Helen and Peter, 30, 14. Now we have Helen as 30. So now to find the ratio for Mark and Peter will be 21 to 14. Now we can simplify this by divided by 7 on both sides. It'll be 3 to 2. So that'll be our answer. So question 2, probability. The partially completed probability tree below shows the voting intentions of shareholders in an election for president and vice president of a large corporation. So we have a Kwan and Minho as the president, and the vice president we have person A, person B, person C. So based on this survey, what is the probability that Minho is elected president with either person B or person C as a vice president? So first thing will be completing the tree diagram, because it says a partially completed, so we need to complete that. So that will be 0.7, because the maximum we can have for the probability is 1. So, and same thing happens. So 1 take away 0.15, take away 0.35 will give us 0.5, and then 0.5. Okay, so now we completed tree diagram and we need to answer the question now. Probability, what we're looking for is when Minho is a president with a person B as a vice president, or Minho is the president with a person C is a president. So what would that be? Minho's chance to get elected as a president is 0.7, with person B is 0.35, plus Minho with the person C is 0.5. So you put that in your calculator, and when you add it together, answer is 0.595. So that's your probability. Okay, question 3. Yuki's car is reported to have a fuel efficiency of 8.5 litres per 100 kilometres on city roads and 7.2 litres per 100 kilometres on country roads. One week, she drove 180 kilometres on city roads and 380 kilometres on country roads. Determine how much fuel she used in that week. So we are looking for total fuel for that week. So CT, we have 8.5, okay? And then for every 100 kilometers. Country is 7.2 liters for every 100 kilometers. And Yuki went 1 week, travel city for 180 kilometers, and fuel, we don't know. And then traveled 380 kilometers in country, fuel, we don't know. So we want to find out the total. So I'm going to use unitary method here. So CT, 100 every 100 kilometers, I'm using 8.5 litre fuel. How much fuel do I use for 1 kilometers? 8.5, 100. Yeah, because to get to the 1, you divide it by itself. And then I want this to be 180 kilometers. Okay, times by 180. So 8.5, 100 times 180. That'll give me 15.3 liters. And here, country, 100 kilometers, 7.2 liters. And again, 1 kilometers will be 7.2 divided by 100. And then we're going with a 380 kilometers for country. So that will be, if you put that in your calculator, you'll get 27.36 liters. So the total fuel will be, I have to add it all up. So 15.3 plus 27.36, I will get 42.66 liters. Question 4, let's have a look. We want to find the percentage error. So tire pressure was measured to be 250 kilopascals. So what is the percentage error in this measurement? The pascals, the short writing unit is a pascal, okay? All right, so first thing we need to know is the formula for percentage error. I'll go absolute error over true value or measured value. I have to do it times by 100%, obviously, because we want the percentage here. So first, I need to find absolute error. So the true value or measured value is the one that it's given in the question. So 250 kilopascals. And then I want to know the absolute error equals half times the smallest division on the scale. In here, scale will be, it had a diagram, but I didn't really draw the diagram, but it was going up by 10. So it's 5 kilopascals. Okay, and then I need to know the percentage of the error. So I'm going to put that into the formula right now. So 5 kilopascal over the true value, 250 kilopascals times 100%, and you will get 2%. So that's the error, percentage error, 2%. Question 5. The network below presents the water pipes that connect a source at S. Source is a starting point. Where's the S here? And to a sink at Z. That's a finishing point, Z. We call it sink. With a series of knots in between. Okay, so there's lots of knots in there. The flow capacity and the direction of each pipe is shown in kiloliters. And then question is to find the maximum flow. Now, to find the maximum flow, we don't need to test all minimum cuts to find the maximum flow. Max flow minimum cut theorem is the key idea here. In any flow network, the maximum amount of flow from the start, the source, to the sink, the finish, is equal to the capacity of the minimum cut. Okay, So once the flow reaches the capacity of the minimum cut, it can't increase further. The minimum cut is the maximum flow for that pipe. I think if you think about it, it'll make sense. The key is you decide where you're going to test your minimum cuts, but the cuts where the less pipes are to find the minimum cut, because the number has to be smaller. So I'm going to cut here and here. I wouldn't cut in the middle because there's too many pipes here, and I know it's going to add up. It's going to be more, so it won't be a minimum cut. So I just cut this 2 because there is a knot here, and I'm going to cut in this 2 here, and then there's a 3 there, and then 3, 3. This one, if I cut it, it has to be 4 or more. So I'm not going to do that. So here I'm going to add 12 plus 13 plus 11. That will be 36. And here 12 plus 13 plus 9. When I add it together, it'll be 34. It's 9 there. So 12, that's a 16 here. So 12, 9 and 16. 12, 9 plus 16. That will be 37. Yep. And then here will be 10 plus 9 plus 16. That will be 35. So which one will be the minimum cut? 34. Okay, number 6. A maths test had the following 5 number summary: 20, 55, 61, 65, 73. Students A, B, C score the results below on the test. Student A got 69, student B got 73, student C got 30. Which of these results would be considered as outliers on the test? 5 number summary given. So let's have a look. 20, 55, 61, 65, 73. The middle one is quartile 2, which is our median, and then our extreme lowest number, and that's extreme largest number there. And of course in the middle is a quartile 1, that's quartile 3. Let's have a look at outlier formulas. We have upper bound Q3 plus 1.5 times interquartile range. Lower bound Q1 minus 1.5 times IQR. We can find interquartile range, which is Q3 minus Q1 will give us 10. So upper 65 plus 1.5 times 10, 80, and lower 55, that's the Q1, minus 1.5 times interquartile range, that will give me 40. With the 3 scores that student A, B, C had, it was a 69, 73, and 30. I don't think anyone is getting around that 80 or higher. So we don't have outlier for the upper bound, but we have this 30, which is the below 40, that counted as a lower bound. Only student C's mark is the outlier. Okay, that's all for this video, and hope it was helpful.